Hey there, in this video we will continue from the point where we paused. Please make sure you have watched the previous video in this series. In the second method, we will build a collision model which covers multiple parts of a robot. For example, in this case, we would like to have a simple cuboid which would act as a collision model for the complete chassis. By doing this, I am saving my processing power, and since the chassis would be covered to protect the internal electronics, this simplification would not compromise on simulation accuracy. So let's get to the modeling. The procedure to build this is exactly same as the one described to build a part from the assembly. Now since I want the origin of my collision model to be coincident with the origin of the assembly, I'll select the graphics area instead of some other part so that the origin of my new part coincides with the origin of the assembly. Now I will start making a sketch which will cover the complete chassis. Now since I am in the collision configuration, I will suppress the visual parts. As you can see, I have not built any collision model for the protrusion which connects the chassis to the legs. This is because I just want to keep the model as simple as possible. Such minute things won't matter much in simulation. And that's it. The collision model and the visual model of the rover are ready. We will now start building the URDF file. We begin the making of the URDF file for the visual model. Open the SolidWorks to URDF exporter. You will find the option under the file menu called Export to URDF. Now, first we need to select the paths which constitute the base link. I will select the chassis frames and the spacers. This is because my collision model covers all these parts. All the separate parts would be merged together into a single step file by SolidWorks. Now, patiently add all the child links. It's a really time-taking process, but the effort is worth it. The SolidWorks to URDF exporter will automatically generate the required coordinate system to set the origins for each child link. Also, if you have a revolute or prismatic joint, axis along which the link would rotate or translate would also be automatically created. If you don't want to use the auto-generated coordinate systems and reference axes, you can create your own and give them as input to the exporter too. Do refer to the PDF given in the description for a more elaborative explanation on how to use the SolidWorks to URDF exporter. Once all the links are selected, click on the Preview and Export button. The reference coordinate systems and axes will be created, and it will take a while to finish the process. Once the process is done, you will find this dialog box in front of you. It shows the URDF properties of each link. If you observe here, even when I had mentioned this joint as a continuous one, the exporter considered it as a fixed one. I I need to change the type to continuous now, and to refresh this page you need to go to another link and then get back to this link. Now I need to define the axis of rotation. Select the joint origin, and I observe that the wheel must rotate along the x-axis, and I will set the axis as 100. Similarly, I will check the other wheels and modify the properties wherever the exporter plugin got it wrong. Next thing to add are the limiting values for the revolute joint. These values vary from application to application and must be set properly so that the simulation results are closer to the real life ones. Once all the required changes are done, select the Export URDF and Meshes option. Set the appropriate folder name and save it. At this point, I would like to take a moment to answer the question, why was it important to have the origin of the base link coincide with the origin of the assembly? In URDF, all the child coordinate frames are defined with respect to the coordinate frame of the base link. Now, the SolidWorks to URDF exporter sets the coordinate frame fixed to the origin of the SolidWorks as the origin of the base link. We don't want that. We want the links to be defined with respect to the origin of the base link part. So that's the very reason we must make sure that the origin of the base link part and that of the assembly, both of them coincide. Now we'll create the URDF file for the collision model. Open SolidWorks to URDF exporter in the property manager. Now remove the base link parts that made up the visual model and instead select the cuboid. Now just select preview and export. There is no need to make any further changes because the collision configuration of motor and wheel parts are used, and also the visual and collision model for the legs are the same, so we don't need to change anything. We would have not been able to do this if the visual and collision models were in separate files. Using configurations to do this has made our life a bit more easier. Now select the appropriate folder and name the package. Now that both the visual and collision models are exported, append something like underscore collision to every collision model step file and paste them into the visual models meshes folder. And then open in the URDF file of your robot. Under the geometry tag, under the collision tag for every link, rename the source mesh with the collision mesh name. Now our separate collision and visual models are ready. We can directly import this into RViz and confirm that URDF file is a well-formed one. Links to download the SolidWorks part, the assembly, modified URDF file as a .zacro file are given in the description. Thank you.